All right, welcome. We're about to break down the essentials of flight planning and monitoring. If you're knee-deep in study for your ATPL exams, you are in the exact right place. We're going to cover the core concepts you absolutely have to know to nail it.
So, here's our flight plan for this explainer. We'll kick things off with a quick refresher on navigation principles, then we'll get into the nitty-gritty of direction, wind, and altitude. After that, we'll get practical with VFR charts. And then, we'll switch into full-on exam mode, looking at the kind of questions you'll see and how to dodge those classic pitfalls.
First up, let's talk navigation principles. We're going to build a really solid foundation right here, because honestly, once you get these core concepts locked in, everything else just kind of clicks into place. Okay, this slide shows one of the most fundamental formulas in all of navigation, the relationship between true north and magnetic north. Now, when you need to convert from a true track to a magnetic one, there's a great little saying to help you remember. East is least, west is best. So what's that mean? It means you subtract an easterly variation and you add a westerly one. This is absolutely non-negotiable for your exams. You've got to know it. And here is a super crucial point. Ground-based aids like this VOR, that's VHF, omnidirectional range, they are all aligned with magnetic north. So when you see that you're on the 076 radial, that's a magnetic bearing of 076 degrees from the station. So, pro tip, always think magnetic when you're dealing with VORs. Let's keep building on this, because out there in the real world, the air itself is moving, right? And we call that wind. This is where flight planning really starts to get dynamic. This slide shows a really simple rule in action. If the wind is coming from your left, you've got to point the aircraft's nose, you guessed it, to the left. This little correction is called the wind correction angle, and it's what makes sure your path over the ground, your track, is the one you actually want to fly. And that brings us to a really key distinction. Heading versus track. Your heading, that's just where the aircraft's nose is pointed. Simple. But your track is the actual path you're carving out over the ground. And that difference between them, well, that's called drift, and it's all thanks to the wind. So you could be holding a constant true airspeed, your TAS, of 110 knots. But a 20-knot headwind is going to slow your ground speed down to 90 knots. On the flip side, a 20-knot tailwind will boost it up to 130 knots. Your ETA, your arrival time, depends completely on that ground speed. Now, pay close attention to this one. This is a subtle but really common exam trap. Performance charts use nautical air miles. That's the distance you travel through the air mass. A good way to think of it is like swimming in a river. If the current is against you, like a headwind, you have to swim way further through the water just to cover a short distance along the riverbank. And that's exactly what's happening here. The plane travels 60 miles through the air just to make 50 miles of progress over the ground. So when you're punching numbers into your flight computer, here's the golden rule. Always pair these concepts correctly. Heading and TAS, that's what the aircraft is doing in the air mass. Track and ground speed, that's what it's doing relative to the ground. Get that right and you'll get the right answers. All right, next up, let's clear up one of the most fundamental concepts in aviation, altitude. And trust me, it's not as simple as just one number. These three altimeter settings are absolutely critical. QNH gives you your altitude above mean sea level. QFE tells you your height above a specific spot, like an airfield. And the standard pressure setting, 1013.25 hectopascals, is what we use for flying at standardized flight levels. Knowing which one to use when is just essential for safety. This diagram just makes the difference crystal clear, doesn't it? Altitude, using the QNH setting, is your vertical distance from mean sea level. Height, with the QFE setting, is how far you are from the ground directly underneath you. Two different measurements, two very different purposes. And this right here highlights a critical safety rule. You've probably heard it. From high pressure to low, or hot to cold, look out below. But why? Well, if you fly from a warm air mass into a colder one, that cold air is denser. So your altimeter will actually read higher than you really are. This means your true altitude is lower, and you're way closer to the terrain than you think you are. Okay, so with the physics covered, let's look at the practical, hands-on documents you'll be using for navigation. We're talking about the VFR chart, your primary map in the sky. The number one rule of flying under Visual Flight Rules, or VFR, is incredibly simple. You have to be in visual meteorological conditions, VMC. All that means is you need to be able to see where you're going and stay clear of the clouds. If you can't maintain VMC, you can't fly VFR. It's that simple. Now, this table might look like just a bunch of data, but this is literally the law. You have to know these specific visibility and cloud clearance requirements for different flight levels and different classes of airspace. For example, below 10,000 feet, you're generally going to need 5 kilometers of visibility, and you have to stay 1,500 meters horizontally away from any clouds. And these are the charts you'll be using. They give you a super detailed view of the surface, the airspace, and all the navigation aids you'll need. I mean, they are just packed with information from terrain elevation and obstacles to radio frequencies and restricted areas. Now, for your exams, you'll want to focus on these key areas when you're studying the VFR chart. The examiners love to test your ability to interpret symbols, calculate a leg between 2 points, and understand airspace limits, all directly from the chart they give you. Okay, let's shift gears a bit. Let's focus on how all this stuff actually shows up in your ATPL exams. Because, knowing the theory is one thing, but applying it under pressure, that's a whole different ballgame. These are the high-value concepts that just pop up again and again in questions, so make sure you know them inside and out. The difference between an ATC flight plan and your operational one is a classic exam trap, and so are questions about what you should be monitoring in flight. And finally, let's talk about the common mistakes that students make, and more importantly, how you can avoid them. Just being aware of these is half the battle won. Please, watch out for these common traps. Forgetting to apply a wind correction will throw off all your time, distance, and fuel calculations. And remember, your ETA is a living, breathing estimate. You have to constantly update it based on your actual ground speed. And that wraps up our look at flight planning and monitoring essentials. We've hit the difference between true and magnetic, how wind messes with your track and speed, and all those nuances of altitude. So as you're getting ready for your exams, really think about the question on this slide. Which of these concepts are you going to master first? Pick one, own it, and then move on to the next. Thanks for tuning in, and fly safe.